What if the most dangerous thing about the sun isn't an explosion? What if it's a pattern breaking? 3 weeks ago, NASA's Parker Solar Probe transmitted data that made scientists stop mid-briefing and say, "This is earlier than expected." That one sentence is the reason you're watching this video. For decades, we believed we understood the sun's rhythm, an 11-year solar cycle, predictable, stable, reliable enough that we built satellites, GPS networks, global aviation routes, and entire power grids around that rhythm. But right now, that rhythm is accelerating. Solar Cycle 25 began in 2019. Every major model predicted the solar maximum around late 2025 or early 2026. Instead, by 2024, sunspot activity had already exceeded projections. In simple terms, the sun is ahead of schedule. Now that alone wouldn't be alarming. Solar cycles vary. But here's where it becomes interesting. The Parker Solar Probe is measuring magnetic turbulence inside a region called the tachocline, the thin boundary layer where the sun's magnetic field is generated. Think of it as the engine room of our star. And the engine room isn't behaving cleanly. Instead of smooth magnetic reversals, scientists are seeing irregular magnetic shear, twisting, tangling, delayed polarity alignment. In plain language, the sun's magnetic field is reorganizing itself in a messier way than expected. That doesn't mean collapse, it doesn't mean the sun is dying, but it does mean instability, and instability in the sun translates into energy release, sometimes controlled, sometimes violent. Here's the part most people don't realize. When a major solar flare erupts, electromagnetic radiation reaches Earth in about 8 minutes. 8 minutes. That's how long light takes to travel 93 million miles. Satellites begin experiencing radiation effects before news outlets finish writing headlines. You don't get a day of warning. You get 8 minutes. Now, radiation alone isn't the worst part. The real threat is what can follow: a coronal mass ejection, or CME. A CME is a massive cloud of charged particles blasted into space. If it's Earth-directed, it collides with our magnetosphere like a tidal wave. Most of the time, Earth's magnetic field deflects the impact. We get auroras. Power systems remain stable, but not always. In 1859, during what we now call the Carrington event, a powerful CME struck Earth. Telegraph systems sparked and caught fire. Operators were shocked. Auroras were seen near the equator. That was before satellites, before electricity grids, before the internet. Now imagine that same event today. GPS satellites are highly sensitive to geomagnetic disturbances. Even moderate storms can cause signal errors. In 2003, during the Halloween solar storms, airlines rerouted flights. Satellites malfunctioned. Sweden experienced temporary power outages. That storm wasn't even Carrington level. Now here's the uncomfortable question. What happens if a Carrington-scale event hits during a solar cycle that's ramping up faster than expected? In July 2012, a massive CME crossed Earth's orbit. It passed through the exact location Earth had occupied just 9 days earlier. 9 days. NASA estimated if that storm had hit, it could have caused trillions in damage, not because the sun exploded, but because our infrastructure is fragile. And that fragility is the real story. Modern civilization depends on long conductive lines, power transmission cables stretching hundreds of miles. When a strong geomagnetic storm hits, it induces electrical currents. If the current is high enough, large transformers overheat and fail. Here's the critical detail. High-voltage transformers are not sitting in warehouses waiting to be installed. They are custom-built. Some take 12 to 18 months to manufacture. If dozens fail simultaneously, replacement is slow. If hundreds fail, restoration could take years. Now pause for a second. This doesn't mean collapse is inevitable, but it does mean probability matters. Because Solar Cycle 25 isn't just slightly stronger, it's accelerating. And Earth's magnetic field, our shield, has weakened by roughly 9% over the last 2 centuries. 9% doesn't sound dramatic, but when your safety margin shrinks while incoming activity increases, the risk window widens. NASA and NOAA monitor space weather constantly. Satellites like SOHO, SDO, and Parker Solar Probe provide real-time data. Predictive models estimate CME trajectories. If a strong CME is detected, grid operators can reduce load. Satellites can enter safe mode. Airlines can adjust routes. Preparation buys time. But preparation depends on accurate forecasting, and forecasting depends on stable patterns. Right now, the pattern is less stable than expected. That's what makes scientists uneasy. Not panic. Unease. Because the sun isn't behaving wildly, it's behaving unpredictably. And unpredictability is harder to model. Which brings us back to the 8-minute window. Radiation arrives first. Then, hours later, the particle storm arrives. That delay gives us some reaction time. But reaction time only matters if infrastructure is resilient. And resilience takes decades to build. We built a digital civilization in about 30 years. It has never experienced a full-strength solar superstorm. That's the unknown variable. We are not witnessing the death of the sun. We are witnessing a reminder of its power. For billions of years, solar storms meant auroras and compass deviations. For us, they mean potential GPS outages, communication blackouts, and stress on power grids. And that's why NASA's language has shifted slightly in recent briefings. Not toward fear, toward vigilance. Solar cycle 25 is unfolding faster than expected. Magnetic turbulence is higher than projected. Sunspot counts are exceeding forecasts. None of these facts alone spell disaster, but together they demand attention. Because the next major solar storm isn't a question of if, it's a question of when. And when it happens, radiation will reach Earth in 8 minutes. 8 minutes. That's not a lot of time in a world that depends on satellites orbiting silently above us. So the real question isn't whether the sun is collapsing. It isn't. The real question is whether a civilization built on fragile electronics is resilient enough to handle a star that doesn't always follow perfect schedules. The sun will continue burning for billions of years. Solar cycles will continue rising and falling. Magnetic fields will continue flipping. But for the first time in history, those cycles interact with a planet covered in interconnected technology. And that changes the stakes. If you want to stay updated as Solar Cycle 25 develops and as NASA releases new space weather data, subscribe and turn on notifications. Because space doesn't wait for us to catch up, and neither does the sun.